Hello, everyone, and welcome to the Geek Nighter podcast. I am your host, Kaivalya Apte, and I am back with another very interesting topic. Today, we are going to talk about FizzBee, which is a design specification language and a model checker, and it helps developers to think about their systems at a higher abstraction level. Now, I know there are a lot of these terms which probably most of us don't understand or don't relate to, but we have JP with us who founded FizzBee, and he's going to help us understand all these terms and understand what exactly FizzBee is and how people can use it to verify their systems before even writing a single line of code. I'm really excited. So, welcome, JP. Thanks a lot for joining us today. Let's start with a little bit of introduction about your background and about your journey to be a founder of FizzBee.
Thanks, Kaivala, for the intro. I am Jayaprabhakar. You can call me JP. A brief intro about me. I started my career around 20 years ago. Most of my career had been at Google, working on distributed systems. Then I moved on to a few other companies. And everywhere I noticed that designing distributed system is not trivial, and for most people without complete background it's very easy to miss out on a lot of scenarios, and losing data is pretty common. That is one of the reasons we have so many tools. Each one solves some part of the problem but not everything. And in addition to being hard, it's also time consuming, both for designing and validating whether the design is correct. Based on that, I was looking for various options. How do we validate our design is correct? There are like techniques called formal verification.
Mhm.
Traditionally this had been used in mission critical applications only because it is too complicated, but recent times many other companies have started using it. AWS, MongoDB, Confluent, and lots of these.
Mhm.
And one thing that stood out is that they are too complex to use, too much math needed, and it covers only a small segment of the use cases which people care about when they are designing. So that's where I thought, okay, can we build an easy to use system where people can get started immediately and add value across multiple phases of the software development. So
Mhm.
that's how FizzBee started.
Yeah, very interesting. You mentioned some of these points when working with a distributed system. I mean, the best way to work with a system is to not distribute it. So it's easier. A lot of failure modes are gone away. But unfortunately, that's not always the reality. We have to distribute systems and we have to work with them. And as you mentioned, there are a lot of cases missed out for various reasons. But then tools like FizzBee and other tools, we'll talk about them, help you think about at a higher level of abstraction and think about the different modes of your system. So I think that is really helpful. And we'll try to understand how all that works. Talking about a design specification language, because those are the first few words in on your website when we talk about FizzBee. What is a design specification language? And could you give some example?
Yeah, if you look at software development phases, right, the first step after we know the requirements is writing a design doc. If you
Mhm.
look at the value, almost everyone understands that getting the design right is important, and not finding a design bug early can be very expensive.
Mhm.
But if you look at the last 20 years, the format of design document has not changed at all. The design
Mhm.
phase is almost exactly the same as it used to be, except for attaching Word document in an email has changed to a shared document. That's about it. Everything else remains exactly the same format and everything.
Yeah.
And most of the design document, if you see, mostly text, like free form text, unstructured, with a only structure you will see is a database schema, API information, and some diagrams. But pretty much everything is unstructured, which is not really suitable for any automated analysis. In the last 20 years of computing, one this is the one phase of software development that has never changed. Everything else have changed. Now the type of software we build has changed drastically, and the applications have changed except for the design phase itself,
Yeah.
even though everyone understands that it has incredible value. And how do we find design bugs? It's also just through manual review. Like, you send
Mm.
out to team members and everyone look at it, and at like, yeah, they read through it, understand, and have some questions. And most of the time the way the reviewers look for is also common patterns and anti patterns based on their prior experience. I've seen this
Hmm.
kind of a system that caused some issues. They see whether it is applicable or do we have any mitigation for it, right? That works for some extent if the only your past experience is exactly the same. But again, with our
Mm.
toolings that change so drastically, what used to work in a few years ago, even a distributed system in on-prem versus a distributed system on cloud, is significantly different. A
Mhm.
queuing system on a SQS is different from a Kafka versus something else on a different provider, right?
Yeah.
So, so the experience also doesn't carry well with newer and newer tools.
Mm.
And another thing is that there are not much incentive for the reviewers to spend a few days reviewing it, even though it's critical. So
Yeah.
what design specification language brings in is adding more structure to certain parts of the design document or the
Mhm.
design phase. How do you describe a design? So most of the, again, there are on a design doc, it covers a lot of aspects. One of the things is related to distributed system is how, what happens when a certain types of requests come in, what are the different types of requests, different types of actions that happen in the system, how are the states stored, and how do we ensure the states all finally make sense, like it remains consistent, there is no data loss, and its system remains fault tolerant, and so on, right? Uh, so all those are usually explained in some kind of a pseudocodish form or lots of text. Now we are adding structure to it. Okay,
Yeah.
we are just saying that okay, these are the specific states, this is how the transitions are, and these transitions are atomic. These transitions don't have to be atomic, which means others can see that intermediate steps. So there are lots of those specific instructions.
Mhm.
In a high level, it would look more like some kind of describing a purely a pseudocode,
Yeah.
but just a Python like language is what I'm introducing. There are many
Mhm.
other languages, they all are highly mathematical. We are just hiding those math at using a even higher level language. So that's what design specification. The biggest value is that it's a precise language with well defined semantics. That means you can use it for any kind of automated analysis. Second,
Mm.
all your assumptions about the system is baked in. Third, because it's precise and all the assumptions are baked in, the reviewers and people who are going to implement, many other your teammates, there are multiple engineers who are going to look at the design and to implement it, right? They also know exactly what assumptions that you have considered, so that they make those same assumptions into the code, right?
Mm.
So all those things can be validated. So the specification brings in that aspect. Now when you say automatically validated, that is what the model checking, and there are other techniques that come in how to do the validation.
Interesting. The problem that you mentioned, right? Even I have observed that, and I've also done that. When you are designing something new and thinking about your system, of course, you write your own document and try to explain it to others. And it's always inconsistent. Even if I write something about the same system after a few months, it will be completely different, right? And that's where the all these documents and the formats they use completely differ, because there is no one language. Of course there is English language, but everyone speaks differently, everyone has their own thought process. But when you have a language like a programming language, let's say, you are bound to follow certain conventions and everyone understands the same convention in the same manner. So I think that adds a lot of value, at least for the programming side. And if you bring that value to the system design side, I think it's also valuable. Let's move on to understanding what kind of systems should be thinking about writing their own specification, or like a description of all the models and the states. Is it necessary to have a complicated system to do that? Or I'm probably talking about the cost of doing this, right? Like cost of doing this analysis and not doing the old way of writing just a document and getting it reviewed with the people. So when do I make this decision that I should use a design specific language and a model checker for doing this, versus I should just use an old way? Is it depending on the complexity of the system? Is it depending on the impact of the errors that may happen in the system? How do I think about that?
Yeah, that's a good point. Most always, one reason formal verification has not reached where it should be is exactly this point, right? The trade-off. There are When starting out, again, the target applications that FizzBee is trying to address is systems with a distributed, predominantly distributed systems and concurrent systems. If you have a lot of concurrency, or you have when I say distributed system, it's as long as the data is stored across two different machines, then it is considered distributed system. Again, there are
Yeah.
different people have a slightly different variation, but to me it's the thing. If you can, so which removes purely crodal apps where you yeah, a server writes to a database, but it's a single database, then yeah, it's generally not that much valuable for the FizzBee. As long as
Mhm.
your data itself is stored across multiple places, without a single owner, then that's a distributed system, which FizzBee and a few other like a TLA plus and P are all really good at.
Yeah.
So on the value versus a cost, the biggest cost is that, again, there are two parts. First one is that initial ramp up time for us to learn a new language, right, or new specification language. Second one is for just specifying for your particular design. How do we design? The first one is actually a one time cost. Okay, how much time you're going to take to learn that particular specification language. So once
Mhm.
you are familiar with it and use it repeatedly, that cost becomes less relevant, and what is more important is how much time it takes to model your system into this specification language. The
Yeah.
advantage that a plain text document has is that the first half, which is the ramp up time, is negligible. It's like free
Mm.
form algorithm that however you will explain to a person, you are going to write it down. That advantage definitely exists for those. So today's tools like TLA plus, that is most popular one, and a P and a few others, they the language is very more complex, so the ramp up time itself is hard. So for people to understand the language, because the initial learning itself, it comes in two parts. One is the syntax of the language itself, and how do we
Mhm.
model the system. Okay, that is again slightly a different problem, but again one time. So those become more complex and time consuming, that that people don't even very often don't cross to the stage of writing the design specification. The Where I'm bringing in is that the syntax being Python like, you should be able to learn, familiarize with your syntax within an hour or so of
Mhm.
training, because it's like very few additional constructs. Concept of modeling, based on my understanding, I wanted to bring that also within that 1 hour time, so that a 1 hour time is sufficient to for people to learn and get ramped up. But from my understanding, or because of the documentation or some kind of a syntax, it takes the second half also takes another 1 hour or so. So I need
Mm.
to bring in make it even faster. So for now I feel it's like a 2 to 3 hours of training would be needed, practice would be needed, to ramp up on how to do the design specification. After that, it is roughly the same time, how much ever the time you take to write a design document in a free form text, thinking about all the scenarios, it is exactly the same. And if we and here we also validate, which means you don't have to explain lots of examples into your design document, because you specify, and from here I can actually generate the examples
Mm.
and draw the all the diagrams. Like you have multiple machines communicating, messages going across, it can generate the sequence diagrams. And
Mm.
and for each state, it can actually automatically generate you, okay, after you send a message and let's say the machine crashed, what would be the current state of various system, and now a recovery process had to start. If it started, how what are the intermediate states it reaches until the complete recovery happens, and what happens if the recovery process itself fails. All those things, it can actually generate both the sequence diagram and the individual states. That makes it easier for you to visualize, and some of the documents, that diagrams that you spend a lot of time on to designing or creating itself would comes out free. So
Yeah.
overall, I believe the design process itself should save a lot of time when we use
Mm.
this specification. And people who have tried even with TLA plus, mostly they say that, okay, yeah, it is valuable if we ignore the ramp up time. And if the
Mm.
language is also too hard, like TLA plus, one issue they are facing is that after 3 months or so, when they're doing their next project, they again more or less forget the entire syntax, so
Mm.
they need to restart again. So it becomes harder. And another issue it causes is that others cannot understand the code, or the specification, which means
Yeah.
they still have to spend a lot of time explaining the design in another freeform text. So this one avoids all those. So now you get okay something that is almost like a pseudocode, like how even you would have probably explained your some logic in a Python or some kind of a pseudocode in your own design doc. Most likely
Yeah.
the language would look like your primary programming language. If you're a Java
Mm.
programmer, the syntax would look like Java, but that's a normal. Okay, even if you look at research papers for 40 years ago, it will look like a COBOL. Okay, but that's how it is, even though
Yeah.
it's a
Yeah.
pseudocode. So here it just brings us more structure to it, and we can do model checking with that instead of an arbitrary language. So
Mm.
that way we can validate and cut down on all your consistency related issues or anything that we want to specify. Safety properties, which are invariants that are always true. For example, we'll never overcharge a customer.
Mm.
It's a safety property, but we will eventually charge for everything they have consumed. Is a liveness property. That's like eventually that's called a temporal property. So those are all some of the requirements, so that we can make the assertion in the design document itself.
Understand. Yeah, I think I agree with you when you said about the ramp up time. And by the way, for me, if I write this language, it would look like as if Java and Python had a baby. So it would be a mix of both.
Yes.
And that's different for everyone. Like whatever experience you had most, you just end up writing like a pseudocode, and it ends up looking like whatever language you used to. The thing that you mentioned about the ramp up time, right? Both with TLA plus P and FizzBee, uh, nowadays people, or I've read multiple articles and also heard some of the like podcasts and people talking about the future of programming, right? Like generally it would become like English is going to be the programming language, where you just explain something in English and the AI model can generate the language for you. Do you think that will also change the way you look at these design specification language? Because then you can still write in whatever your native English language is, in whatever format you want, and the AI model can generate the design specification language for you. So that also takes away the learning curve that you have for a design specification language, right?
Yeah, exactly. Yeah, actually, I was just talking about this feature to another person as well. So exactly the same set of points. There are more to. You mentioned the first part, right? How do we design in a with a specification language? Like how can we use AI to write the specification itself?
Yeah.
And another one you did mention is programming itself, right? Can it generate most of the code? Okay. And yeah, and I understand how it ties out to the ramp up time. The issue is a even today can generate some code, but how do we validate that code is correct, because it
Yeah.
hallucinates? Okay,
Yeah.
for a smaller problems the code is perfect code, at least I can compile to see even compiling.
Yeah.
When I try to use it to generate for more intricate logic, it misses out. Okay, there are a lot of
Mm.
issues. Okay,
Yeah.
now do we even are we both in the same page? It's like a two-person communicating, right? Two
Mm.
human beings, even a two smart people will, any imprecise language will have a conflict. The entire legal system is depending on how do we understand a text. Okay, there is okay, so
Yeah.
that way there are definitely ambiguities. But even if AI can generate the specification, if it can generate in a language which I can understand, then I can say that okay, yes, you have understood it correctly.
Hmm.
Okay, the precise syntax may not be like it's being able to write a language write in a specific language versus being able to understand what is already written. They both are
Mm.
slightly different. They are correlated, so at least it has to be readable. So people should be able to read and understand the specification what it does. So now whether it is someone else generates that specification or an AI generates it, all everyone in the team should be able to understand that okay, yes, this is exactly what it is doing and this is what
Yeah.
I'm expecting it to do. So that part needs an understandable language. And more and more AI takes up, more and more familiarity with that language is going to go away, which means closer it is to what people are familiar with makes it more, gives us more confidence to even using that AI models, right? AI generated models.
Absolutely.
The second part of it is that even if it generates a model or specification, we still need ways to validate it, to say
Mm.
that okay, yes, it addresses okay, it expressed what I wanted it to express. Now what we expressed solves the problems and doesn't introduce any new problems. That comes in, that's where the model checking happens. Then again, can we write, now that we have all the state spaces and a precise language to describe the design, can it actually generate the code, actual code in various languages we want? And how do we validate that code itself is correct? So there are like different
Mm.
phases. So right now I'm not looking at into AI as a primary user for generating the models or generating the code, although I
Yeah.
do believe it will happen. And that is
Mhm.
where I believe having a model checker and a way to verify, that's another thing we are doing, working on right now, is how do we validate the code matches the design. So these two are
Mm.
going to be critical, and they are compute intensive. It's not an intelligence thing, it's more like a meticulous thing. It's like doing a very complex math problem. You don't need to think, you don't need creativity, but you need to be meticulously doing all the multiplication, all the numbers, right? So those are going to happen more like a old fashioned way.
Mm.
So that's what FizzBee is going to do.
Absolutely. Yeah, it is the same thing that AI can write code for you, but at the end, you cannot trust it. You have to review it. So, which basically means AI is not going to take away our jobs. We still need code reviewers. And that does make sense. That takes away some effort of writing that language, but at the end, you need to understand how it works to verify that the output is correct. And that makes sense. Let's probably take an example here, right? Since I love traveling, let's take an example of, let's say, a travel booking system where I want to design a system and I want to book flights and hotels when I go there, and probably also taxis and things like that. How, as a developer, should I start thinking about modeling the system first of all, and then modeling it in a way such that I can write a design specification for this? So how would the approach look like?
Yeah. Uh, so let's say the exact problem. This is the travel booking site. This is also one of my favorite examples because it covers most of the things that we want, and it is simple. The other examples are banking and a few others, but yeah, this
Yeah.
is my favorite. One of my favorite. So here, there are as an application. Let's say you, as you said, you are building a travel booking website, right?
Hmm.
You don't have full control over all the other entities. Now there are, and from a requirements perspective, from a business requirements, there are lots of aspects. Okay, but again, when it comes to purely a distributed system, let's take one subcomponent to it, which is how do
Yeah.
we ensure we when a user confirms a booking, we want to be able to say that okay, all the legs of the flight are booked, and the hotel and car and the payment is made, or none of them happens. We should never reach a situation where the hotels is booked and one leg of the flight is not booked. That would be
Hmm.
bad. How do we venture all or none happens? And again, in this case, it's a purely a distributed system. You don't even have a choice of having a single machine because they go through different entities, different business
Yeah.
entities.
Hmm.
So so again, here again, we have lots of requirements. And if you look at the typical design doc format, we would talk about various other things like, okay, what are the APIs, how will we ensure that, how will we communicate with the other vendors or their APIs. But one subsection would be, how do we ensure that everything gets booked and not. Okay, if we
Hmm.
take out only that part, again, that is where a real implementation versus a design specification is different. Is that in the implementation everything has to be put together. Here you can extract only this specific algorithm and then describe it. In this case, there are again multiple approaches. One solution is called two-phase commit. Basically, you do a, what's it called, hold flight, you can say put on a hold, right? So you make a hold request to each of the flight legs and the hotel and other systems. Once everyone said okay, yes, the flight is held for you, then you can issue a confirm
Yeah.
and make the payment. Okay, so then it ensures that everything is booked for you. And
Hmm.
only guarantee they have to do is that they do have to support this kind of an API where hold and release, and during the hold until the confirmation happens, they are not supposed to sell it to someone else. So
Yeah.
that guarantee they have to provide. As long as that guarantee is present, now you have the remaining logic you can describe. So the same exactly what you would do. You'd say, okay, I have my booking service and I have these participants, service provider. No, so too many service. Let's say call it participant itself. So
Hmm.
your booking service would make like a hold request to each of those,
Hmm.
and Oh, then they would respond back and to say prepared or abort. And the second phase would be like if everyone said prepared, I would say okay, commit. Otherwise, say abort, right? Release. Only this part of the algorithm can be extracted out. And in here, you don't even have to. This is where the thinking at a higher level of abstraction comes in, because here you don't need to talk about the APIs, whether they use XML over HTTP or custom protocol or even gRPC. I hope no one does, or JSON REST API, whatever they are using. Yeah, you don't really care what programming languages they support. It doesn't matter, or what
Mm-hmm.
you are going to use. It doesn't matter again. And many times you don't even have the API at the time of designing because the business deals haven't even gone through yet. So you can still abstract out, and all you need to say is that okay, they have a state variable that says confirmed or not, okay, or what state it is, and some kind of a return value to know that whether the whole request succeeded or aborted or any.
Mm.
So that then you can actually describe them into like a purely a pseudocode, because at this point you will see okay, first this happens, then for each participant send a prepare request. If the return it returned failed, yeah, basically it's an algorithm at this point. You just describe them, and you're hiding out any network or any of those into the algorithm itself.
Mm-hmm.
The language has semantics such that you are making a call to a different entity. It means it is going through. It would mean that it's an RPC equivalent call. So message may never get delivered, which or the system can crash. You can deliver, the response might not have come, and those are all the scenarios the model checker can simulate. It's more like a
Mm-hmm.
simulation. So we
Yeah.
you look for every possible scenarios, and what if one succeeded, one failed, and one succeeded, but the timeout happened because you it came much later. And those are the things you can specify. And then again, the expectations, the safety property is that you should never have one thinking that it is confirmed, another one saying that it is not confirmed, not even in the
Mm.
whole state. But so that should not never happen. The second scenario is say liveness property is that every time someone makes a booking, we have to eventually confirm that to every vendor that we have confirmed for everyone or aborted for everyone, so that they are released back so that they can sell it to someone else. It should never
Mm.
happen that you are requested a hold, someone else rejected it saying that okay, one flight might be booked out, so they said no. Now you should not keep holding it forever, even
Mm.
if your system crashed or whatever it is. Now how do
Yeah.
we specify those requirements? So all those would be like the entire thing would be less than 50 to 60 lines of specification code. Okay.
Mm-hmm.
Because on a high level you can see that the if you extract out all the details, this is the only one. And another thing we talk about as a higher level is that we can ignore all the specific details, whether the customer name, we don't need it for this particular algorithm, even though it is going to carry the same message across. We don't need it, right? Or what are the reasons the flight can reject? It could be that particular airline, this passenger is in a no fly list because they did something bad. If we don't care, we just say okay, it's not allowed to book. It could be the
Mm-hmm.
flight itself never existed, or this, or it was sold out, right? We don't really care. We just know that okay, one of them did not go through. So that is
Yeah.
sufficient. So these are all, we can remove all those details, and we can say that okay, as long as for this particular resource ID, this is the same transaction ID and everyone has the same transaction ID, we are good. Okay, so that is how we would describe in this specification. Yeah, that's where the specification language comes in. Now when we run it, it can actually check all these cases, the liveness property and this, and it would say okay, from the beginning, this is how the states start to transition from this state to next state. The RPC can fail, RPC can be retried, and there are many of those cases you can do it. Like in a banking example, yes, retry would happen, but it should not withdraw or pay someone twice, right? So all those scenarios also have to be tested. So they would be modeled in your specification, and we would actually test for all those scenarios automatically. So once
Interesting.
it is confirmed, of course, it would generate all these diagrams and all. So now you can share it with the team. Hey, this is how it is going to behave. They can also play around. And one feature I'm trying to add is we will also do more. It's more like sometimes in a, even though the design is described in a document, you may not want to go through everything, and you can ask for hey, what happens in this situation. Okay, so that can also happen. I'm going to add it. That is again a small LLM component to it. I have all the specific state spaces. I can say that, okay, if this kind of event happens, or this sequence of event happens, how will the system recover? Now
Hmm.
we have those information. We can generate the state spaces, or we can filter out the state spaces and show the sequence diagram. Okay, this is how it can. From here, these are the sequence of events that would get back into the consistent state. So those reduces the review time as well, and builds confidence among the team also about the system you're designing. So that's where the purely
Interesting.
the design specification and model checking part comes in.
That makes sense. So, at a high level, whenever someone starts to work on designing a system like this, they need to be isolate themselves or separate themselves from the implementation details and really be at a higher abstraction level. They shouldn't be caring about how the data processing will happen, what kind of APIs are available, what is the state, what kind of database will be used, and all these are implementation details. And I have to be at a higher abstraction level where I think about these different boundaries, and not even care that these are systems that are distributed over network, right? Like, we just talk about these components and specify what kind of failures can happen, and then the expectation, and this is what I expect from the system, like all or nothing behavior, that the example you took. And then the model checker will run and make sure that this model is good. Most of the problems that at least I have seen in my experience is dep depends on the implementation, right? Like, I have a bug, and that's why this all or nothing guarantee failed, for example, right? Because let's say in some condition I'm not rolling the value back or something like that. So there's a lot of dependency and coupling with the implementation itself when I am defining correctness or safety of a system, right? So, how do I say, or how do I know that is it a problem with my model where I like the design of the system, or it's a problem with the implementation, right? So, to rephrase my question, what I'm trying to ask here, let's say I have a bug in my modeling itself, right? What kind of problems will this model checker identify? Is it just that this is not a valid state? It may happen that your model doesn't reach or your system doesn't reach this state. Or how does it make sure that it's at the higher level of abstraction and thinking about, is it is the system design problem or not?
Okay. No, actually, model checker cannot make that decision whether it is
Hmm.
a system design problem or not. But it can only
Yeah.
say that for the system that you have described, whether it meets the assertions or the liveness properties that you have specified as expectations.
Hmm.
Okay, and your point is valid, which is how do we know whether it is at a right level of abstraction? As a formal verification or formal methods itself, they don't specify whether it should be at a higher level of specification. And if you look at most rigorous systems, where in some of these really critical applications, they actually go through first at a very high level of abstraction without even with the only minimal amount of state information. Then they design at a slightly lower level of abstraction, and they can actually go through multiple levels of abstraction to reach to be able to prove that the code itself is matches the exact specification, and each level,
Hmm.
each stage adding more details to it. Okay, so
Hmm.
that is possible. So everything is kind of abstraction, right? And because it's not really a boolean, okay, high level and low
Yeah,
level, it's a spectrum. And
absolutely.
it's just that we need to see. So if you remove a lot of abstraction, again, one is that the design might be a little bit very generic, and it can work with, let's say, any kind of a database and any kind of a messaging platform. But for some performance reasons, we may want to restrict on the type of databases we want to use. Then
Hmm.
we can use some of the specific features that they provide. For example, let's say an object store. Traditionally, for example, S3 didn't even have a conditional
Conditional
write.
rights.
Okay,
Hmm.
so today it has. Now if you have this feature of conditional write, now suddenly you, some of the optimization which were not possible before could be possible. So now you
Hmm.
can add, you if you know that this is what you're going to use, you can add that information, and it increases your the amount of your I mean uh, widens the type of design you can, because you're restricting on one, and which
Yeah.
means you get more flexibility. So this concept, starting with a higher level design and then lower level design and so on, is called refinement. And right now that's not my focus, because I don't believe most people would do it. And all the systems that I production systems that used TLA plus and P and all, no one have used refinements.
Okay.
So starting with the highest level of specification and uh, getting to the second level and so on, it's only mostly in the research space is what I have seen. The research teams of big companies and also in academia, it's where I have seen it. Otherwise I am not, so that's why it's not even part of my what I'm considering
Mm.
implementing for FizzBee. That said, technically you can do it without it. Okay, it's just that with a
Yep.
refinement as a built-in feature, it provides certain kind of makes a lot of things simpler. Okay, but in any case, from as an implementation, we just have to see what level of abstraction is appropriate for the system you're building. Okay,
Okay.
the advantage of doing it at a slightly higher level is that it also reduces the amount of state space. If you say that okay, I have one variable versus two variable with a specific set, or if you just add a cache to a system, right, the amount of state space increases significantly. The time taken to model check itself would be huge compared to not
Mm.
having it. So the, that's something that we need. It's more like a trade-off, and it's similar to design doc. Sometimes you can say a few lines, or you can go to much more detailed. So it's exactly the same.
Absolutely. So probably it also comes with experience, right? Like experience with writing these design specifications as well. If I have to write it today without having any experience, I might really go into the implementation details, or I would still keep this in mind that, oh, I have to be at the higher level of abstraction and be at so higher level that I miss out on some of the states, right? So it is possible, but probably it comes with experience and probably getting it reviewed, and probably some of the feedback that we get from the model checker itself, that probably this state is not even considered by the model, so probably I have to think a little bit lower and not this level of abstraction. So I think that makes sense. Going back to the example that you mentioned, right, like the booking thing, that okay, I book all the legs of my flight and then I go ahead and book my hotel and also a taxi. And for example, this happens, and then as you mentioned, that I assume as a developer that there is a state which can hold a booking, or let's say revoke a booking or confirm a booking. But that again depends on the implementation, right? So if I am modeling a system like that, but let's say whatever the taxi booking service I may integrate in the future, they do not have such an API. So how would that work? Do I have to change my model again, or how would that work?
Yeah, of course. Yeah, if you yeah, that's another reason why we would need a model that is easier to understand, because it's
Mm,
possible that people don't. We in model we can say make some assumption which is invalid, not possible to be implemented. Right. One. So in this case, we have to update the model. Okay. In this
okay.
particular example, it may not even be possible to atomically confirm whether the
Mm,
certain taxi is available or not. Good thing is that almost in that case again you can book it and cancel it. That's what you need to do. Okay, as long as they have a free cancellation, you're good. Most likely you
yeah.
do a business deal. Okay,
Yeah.
many times that's how it starts. Okay, so that said, you still have to make this kind of a model actually.
Mm,
And the very related example which we also had an issue was in the model it was specified like two events would be in a single atomic transaction plus model actually. And it's like unless someone actually knows that these two are going to be in the same transaction, which is not possible to be implemented during the review, the person who is modeling would think that okay, yeah, it works because model said it would be consistent. The
yeah.
developer would, if they didn't know about it, that this specific set of symbols imply it is atomic, so they're going to
Mhm.
say that okay, you write to two separate databases, but one of them is going to fail. Yeah, then they would start patching. Okay, so ideally, yeah, the implementation, model also should try to ensure that it is implementable.
Okay.
Okay, so this is another issue where if TLA plus kind of a models which are generated by usually by research, some of the researchers in the whereas developers are different, can cause these kind of issues, right? Because in an
Mm,
implementation, I may not even have the same kind of a guarantee. And yeah, that's an issue, and that's again, it's purely a specification language issue, because we need to make it more explicit and have it close to the developers, and developers can also understand the model so that we know we are modeling them correctly.
Got it. I think it makes sense. At the end, designing and implementing these systems is not really easy. It's not really straightforward, and there's always going to be some exception. And the point that you mentioned, that there's always this two-way feedback where you write a model, or you design, or you write a specification for your design that gives you feedback on how you should implement it. But then at the implementation time, you may realize that, oh, this is not possible, because let's say things are not under your control, like you're trying to onboard some other taxi services in some other country, and they don't have a concept of transactions, for example, right? So it is possible. So you have to give this feedback to the model itself and adjust your model so that both are in sync. Otherwise, okay, you have a model which works in theory, but when you try to implement it, it's just not possible. So I think this two-way feedback thing should be considered, right?
Yeah, yeah, that makes sense. Yeah, that's true. And another reason implementation can diverge also are performance
Yeah.
reasons, right? Sometimes just
Hmm.
adding a cache, a modeling guy may not have cared about performance,
Hmm.
but the moment you have a cache, you are going to have some stale read. Now,
Yeah.
does its system really work as you expected? May not be obvious. Okay, again, so that is where we still need ways to also ensure our implementation matches the design. But
Hmm.
then, really, if the design is bad, your implementation is going to be wrong most of the time anyway.
Yeah.
Okay, it's when we are building a bridge, we need our blueprint, and the blueprint has to be solid. Then yes,
Hmm.
so that might be corruption, and the specification for the construction may not have met the design. But if the design is wrong, the bridge is not going to withstand anyway.
Absolutely.
Okay, so at least that part should be valid. The second part is the implementation testing. So that's another thing. Since we have the model and we know what states are valid and what is not, we can
Hmm.
actually generate test cases. And technically, we could generate every possible unit test for the valid scenarios, and a certain amount of integration tests and end-to-end tests also to validate the concurrency issues. For the example, like you mentioned, if some consistency issues are going to be violated it because of an implementation change, these testing or tests that are generated can actually find them. Okay,
Hmm.
in and another beauty is that if you're starting really from the beginning, it as soon as your modeling is validated, right, your you get all the test cases.
Hmm.
You have a true test driven development at this point. Okay, because you have the tests and now you just have to make the test pass. So we can say that, okay, that becomes also a scorecard or some kind of okay, how your progress report indicate how well your implementation team is also progressing, uh, what's pending and all those cases.
Yeah.
So that's the current work that I'm doing right now, including this is called model based testing that we are working on
Hmm.
to validate, and that would mean building some kind of a continuous build where we can actually generate, and that way, whenever all through your implementation, it can continue to monitor. And that also means that if your implementation diverges significantly, you have to go back and update the model. So that is another issue with the design doc, because people don't go back and update the design doc.
Hmm.
There are two reasons. One is that design doc is anyway not that useful. Second reason is slightly political, or
People
because
problem.
there is
Yeah.
not much. Sorry, what's it?
People problem.
Yeah. Uh, okay, that's a politically correct way of saying.
Yeah.
It's more like okay. To be honest, writing a new design doc is valued more than updating an old design doc
Hmm.
from for someone who is applying for promotion, right? From a promo, uh, like, okay, look, I've designed these systems.
Yeah.
Yes, so which means I would rather create a new design doc than update a old design doc. Okay, so
Hmm.
they're going to diverge. Whereas in a model, it is going to be checked into your Git repository. Now they have to be updated, otherwise your model, it will flag that okay, it's violating some of the design assumptions or the model assumptions, so it doesn't model, it does diverged. So
Okay.
that's a thing that we will be doing. There
Hmm.
are a few other features also, but yeah, this is the current one that I'm working on to ensure
Okay.
design implementation matches the design.
I want to understand this a bit more, but before that, I also did an episode with Antithesis, and it's about like simulation testing and testing that your system works in different states and making sure that you're uncovering all the hidden problems that your system may have as soon as possible. And that works at the implementation level, right? Like your code is there, you run the simulation testing and you figure out all the problems. How does that tie with this kind of testing where I'm testing at the design itself, right? And do they go hand in hand? Or if I have a system and I can run simulation testing on it, do I need a model to verify that? Or what is your thought on that?
Yeah. Okay. So I do. I did watch that episode, and I get this question all the time. And the thing is, there are like multiple. There technically, the first phase, the modeling and implementation testing are complementary,
Hmm.
and because the modeling, see if the design is wrong, yeah. After the implementation, if antithesis or let's say the DST, deterministic simulation testing, finds out an issue,
Hmm.
it's already a bit late. Again, if it is a implementation issue, yes, you're good, you can fix it.
Yeah.
But if it is a design issue, it's going to take much longer to fix, because are you going to throw it out, or are you going to add lots of patches to sometimes may throw out a certain piece of code and re-implement
Hmm.
and all, right? So time is already passed. So
Hmm.
many times, so basically this one would find the issues upfront so that you're designing the right thing and implementing
Hmm.
the right thing. And that one would be like after all the implementation is done, yes, you can validate it. Okay. The second issue is the state space. In
Yeah.
at a model, I can constrain myself to the important scenarios for
Hmm.
which I need to validate. Whereas at an implementation level, the state space is huge. Okay. And they are also, if I remember, focusing on end-to-end testing.
Hmm.
Okay. Although it says that okay, end to end everything is correct, but the thing is that state space is so huge, it is going to be incredibly expensive. Just an
Hmm.
example, let's say two threads, three atomic steps, or four threads and three atomic steps would be like 400k individual states. Okay, it just state space grows so exponentially. And
Yeah.
even if those two are totally independent of each other, and there is no way of knowing whether they are actually independent unless we can really understand the code, which mostly is not going to be feasible.
Hmm.
That would leave, that's where the model based checking helps. Now from here I can actually generate the most critical tests, just enough to check for the edge cases,
Hmm.
like I'll generate all the edge cases. Then I can say, for example, one thing they did mention was they use some heuristics to ensure that we check for the interesting cases. But then the thing is that how do we generate that heuristics itself is random. You try out
Yeah.
randomly and say if it is reaching a different path. Okay, let's say you have a scenario that happens one in 100 times. You need to generate the expected number of trials needed to generate that itself is 100. Okay, but again that is a 70% confidence interval, right? Now if
Hmm.
you increase more, you want a 99% of the time it has to reach, then you need a lot more trials
Yeah.
to generate. After
Hmm.
that it can decide whether to explore that path or not. Okay, so the considering the state space grows so huge, by definition in a DST we cannot test for exhaustively. Okay, and again by definition again it would actually automatically test for common code path. That's how it is. So huge, and there are like a lot of code path would be executed more often. That is a path that is going to be tested more often, not the interesting parts, unless they have more and more uh, heuristics. Now where the model based testing helps is that it can generate those heuristics. It actually can say that these are the inputs where it is going to do. Then technically it can even become an input to distributed deterministic simulation testing
Hmm.
uh, to create the appropriate test cases. But again, if you are doing that, technically we can actually do a majority of the tests can be validated with only a unit test, and only a very few end-to-end tests would be needed.
Yeah.
Then it significantly reduces the cost.
Okay. Okay, I think I understand that. And so basically, they both should go hand in hand, ideally. And with model checking, you get the feedback way early in the process that your system is not still there, but you have a problem with your model itself or your understanding of the system itself. So you can fix it right away. And then implementation would have lesser bugs overall because your model is good. And then your implementation can still have bugs, so you need simulation testing so to improve that. So they both go hand in hand. And also the second part that you mentioned is the cost, because cost of changing the design is really high as compared to cost of changing some implementation. So that is a good point, and I totally agree with it. But let's say I have a system that is already there. Like I join a company and the system is already there, like the booking system, right? And there's no model checking, or there's no concept of design specification. It's all spread across, let's say, 10 different documents. And I have an implementation and I don't have a simulation testing. Can I still try to implement or have a design specification language? Is it worth it given that the system is already in place? Or does it mostly make sense for new systems that are not in development?
Okay, I might be biased here. I would say yes, do it for all old system as well. But the thing is that
Yeah.
at the end of the day, it's like if that particular system is critical and you are seeing continuous development within that system, then it becomes important. If that
Yeah.
system rarely changes, you probably don't want to touch it itself, right? Because
Hmm.
you're not even having active developers working on it. But looking at TLA plus and how it was used in other systems, many times they started with existing systems. Okay, they are making some changes and they're seeing a lot of bugs coming up. They might be patching often, and how do they validate it? But they want to avoid this kind of scenario. So
Yeah.
again, AWS has multiple papers related to how they use TLA plus and for formal methods in AWS. You
Hmm.
can see it started off for existing system. There are some cases where they had some bug reports, but the model check they couldn't reproduce it, whereas their model checker was able to find out. It's like a 31 steps in the stack. Only then it would actually they can reproduce that particular bug. Again,
Okay.
so those kind of things they were able to do it on the existing system. But again, it's again a trade-off, right? It's where do you focus on your effort? It's, I would say, wherever your active development is. If you are continuing to make some changes to that part of the system, yes, you need to at some point you need to start modeling. Okay. But again, the obviously the value is greater if you are doing it from the beginning.
Yeah.
But then mostly people would start with an assumption that their design is correct. So it's easier to say, okay, look, there are some bugs. We need to validate it at a later point in time. Is a lot more easier to sell than uh, upfront say that okay, prove that your design is correct and then do it. Especially when the market, when market in the sense like the developers are not fully aware of formal verification itself, or even if they heard about it, they know that it's too complicated, so they are not going to try it. So initially, it is going to come from existing systems where they're making some small changes and say, okay, let me add formal verification.
Okay. That makes sense. And that is a good advice. And I ask this question on behalf of all those engineers who, after listening to our podcast, going to go there to their manager and say that, hey, we need formal verification because we have too many bugs, right? And that way they can justify why formal verification could be useful even for existing systems. So that does make sense. And again, it's at the end it's about trade-offs. And if you have a lot of bugs and you're not able to understand if it's a design problem or an implementation problem, probably it's worth having a system design specification even to understand and prove that it's a design problem and not only implementation problem. So I think that makes sense.
Actually, that is a little harder to convince anyone that it's a design problem or implementation problem, because there is also uh, it's like, yeah, if you talk to an engineer and say that your design is bad, it's going to go up really
Yeah.
bad. Okay.
Yeah.
Instead, you say, okay, it's an implementation bug. Yeah, sorry, I was lazy or I was careless or I just, yeah, that is easier to convince. Saying a design
Exactly.
problem is hard. Okay. So
It's
now
a
it
ego
has to
problem.
be, yeah, again, it's again a people problem because I did face it. Okay, I did face
Yeah.
it. That's where I started. Okay, let me model it with TLA plus and say, okay, prove it, and then it was yeah. That's where it started as well. It may have to be pitched differently. Saying instead of saying that prove
Hmm.
that it's a design problem is not going to be practical. In maybe it has to. It can come from a top if people are, if a CTO or senior engineers and all are saying that okay. Uh, let's go for correctness. Let's say that our system is correct. This particular component is really critical. Usually, things related to billing. or a large scale system managing customers data, they would be very critical. Like a chat app losing some data, people don't care actually.
Hmm.
They do, but not as much as losing some money. Okay, so yeah, that's where it is. Mm.
That makes sense.
Those
Yeah.
apps maybe mostly from a top level would work, or from the bottom up it has to become more like people should take pride in showing that, hey, look, my design is correct, I know this topic. It's like a
Mhm.
few years ago how like everyone went on to say uh, microservices or cloud, and because it's also cool, so it has to reach
Yeah.
either the coolness factor or a top level mandate. So,
That makes sense, and that's really a practical thing. Depends a lot on the org that you're working on, depends on your managers and team and whatnot. And it's a really hard problem. It's not easy to prove that it's a design problem. Talking about design problems, right? What in your experience have been some of the design problems that a model checker has identified? If you can give some examples there.
actually, I haven't used formal verification rigorously in any of my work. Only time I used was in my previous job for TLA plus, but that is
Yeah.
again I already know that there was an issue. It was more
Mm.
to prove, after trying to convince folks that, okay, look, it's a design problem in the existing design. We need to, and it's an implementation problem. That's why I actually interrupted when you were talking about that point as well. So I did model it with TLA plus to show. Okay, it was actually a usage based metering system. Oh no, I don't want to name the company,
Yeah.
but then I worked in only three companies. People can easily know, figure it out.
I
So
think I already know it. It's fine. Could you probably mask the problem statement itself and probably
yeah,
model it in a different way so our viewers can understand what kind of design problems are we talking about when we surely know that this is a design problem and not an implementation problem, at least for an existing system?
yeah. One is, see, usually from symptoms of the problem, you can identify that it's a design problem or implementation problem. The biggest is if a similar type of problem keeps coming back multiple times.
Hmm.
it, it's like very related, but for a slightly at a different place. You patch it and you do next one and there again another patch and so on. Okay, then you know that it's a design problem. Otherwise it's imagine like you're building where there is a small leak, you'd say, okay, yes, I need to fix that leak. That's our first thing, and that's also the most pragmatic thing. You don't want to rebuild everything, but if
Yeah.
it happens all the time or frequently at multiple different places, if it is again a same place, you're going to say only that section need to be replaced with a better quality product. But if it
Hmm.
happens at multiple places, but it's a related problem but happens at multiple places, then you know that it's going to be a design problem. Okay, if it
Hmm.
happens frequently, because, and actually this again, Leslie Lamport has lots of cool quotes. Basically, if you haven't formally verified your system, then every change you are making is a patch. Okay,
Hmm.
but then I don't want to go that far, because he more or less made formal verification for software systems. TLA plus was the first widely used formal verification tool for software. So he would be a little biased, but I don't want to go as far as that. But then usually it's like a amount of patches to the similar issue. That is when you're going to see mostly things related to consistency. Like you have data at two places, so you can actually say that, do look, data have already diverged, so I know that it is wrong. Okay, that's a
Hmm.
much more easier way to say. And the problem is that many times you don't even have the data. You think you store it, you update it, and then lose out that information also. That is also possible. Then it becomes even harder to prove. But there again, there are symptoms. That's how you got a bug report in the first place, which means like somewhere, okay, I don't have all the data, but I'm overcharging the customer. Okay,
Hmm.
or I did not give a loyalty point to a customer, to a driver. Okay, I'm used that term, but yeah, that also I've seen. Okay, so people can figure there are always some kind of an inconsistency. That is the most common area. And the other one is usually again things related to, if there you have queues, there's a good chance that you're going to have this issue, because during testing and all, right, it would be like whatever you publish, it will always reach the other side because you have very limited load, and it would reach in such a very short duration. Okay, and you might even say that, okay, in the on a receiver you can have two multiple database updates. Okay, but then even if you think it is the queue is 100% reliable, which is not, but even otherwise, you unless the handler itself is purely idempotent and tested for idempotency, things can go wrong. Which also
Mm.
we have seen cases like the two database update. First one wrote to a data and or inserted a row. Second one published like updated some number. Okay, the now on a retry, the first one would fail because the what's it called, duplicate row, right?
Yeah.
The second would never happen, so it's not really idempotent. So unless
Mm.
people have same thing can happen for every possible updates. Okay, update or delete, you the first step might have already deleted it, so the second step would never happen. So
Mm.
that happens often. So these are common areas where this issue happens. But then the thing is that if you already know it, very likely you would catch these kind of issues in the design itself. That's where the looking for patterns and anti patterns come in. So if we already know, but based on the design, okay, look, you're updating a two databases, and it doesn't matter what happens, there is always going to be are going to go out of sync. How are you ensuring go they come in sync? And would be a common question that we need to ask all the time. Anytime related data, derived data is going to be present, then what happens when there is even a coding bug? Even if your entire system works correctly, you still can have some coding bug, you made a wrong push.
Yeah.
Okay, so which means you need a source of truth. So define specifically where the source of truth is, so that then can you have a recovery process that can actually, without stopping the rest of the system, can I recover while continuing to process? Because again,
Mm.
in that case, we need to store those type of information, appropriate transaction ID, and the derived state also should maintain that transaction ID to ensure that it is not reinserted by mistake, or it can identify that this transaction is not written before. Those kind of things have to be kept in. And this again, where again the instead of relying on these common patterns and anti patterns, proving with a model makes it a lot simpler. You don't
Mm.
really need to think through all these kind of cases, because again the experience is, again, the problem with experience is that it takes time to get the experience.
Yeah.
So yeah, and you also have to think through, which also you don't have much time to do that either.
Yeah. That's true. It takes time, and also the experience can leave the company as well. So that's the common issue that I have faced, that people design some systems and implemented and left the company. So now there is no context at all, and people who are maintaining it, they have to do some patchworks because there's not enough understanding. There's not enough historical context, and that does make sense to what you mentioned. And you also mentioned a good example of this idempotent behavior. But let's say I design a system like that, just going back to that example because I'm just curious. So let's say the first write itself fails because of duplicate row, and the second statement isn't called. How would you fix that? Is it really a fix at the design level, or there's a lot of things that depend on the implementation, right? For example, if you are able to, let's say, if I have to talk in a very crude, low level language, I just catch that exception that, hey, this failed because of duplicate row, and then do the second statement, right? So there's also a little leak from the implementation perspective. So, how do I keep my mind clear in that sense?
Actually, that's again a little hard, because again it's like you mentioned, like you catch that particular type of exception and then handle. Now there are
Mm.
like the error codes might be different. There could be multiple scenarios, and
Mm.
it also means that again, if it's a design issue, the implementation, if it is an implementation issue, and if this kind of thing would be sufficient, the second step where you're updating, making a second update, right? That also that has to be idempotent.
Mm.
Otherwise, you're getting the exact same issue. The
Yeah.
idempotency issue goes back to other place. If it happens at multiple places, then it's clearly a design issue. Okay.
Mm.
Now, sometimes again, like any issue, you can fix it with a implementation. So many patches can eventually fix everything, right? But then it's again about cost. Okay. At some point, the design, doing the correct design would actually lead to much simpler code. Okay.
Mm.
Many times, like again, same example, like now every step has to be idempotent. Okay.
Yeah.
Now, was it caught in the design? Okay, these all have to be idempotent. And sometimes these two separate updates could have been in a single transaction itself. Could it have uh, been possible? Then again, then it has to be a design. At the design time, you would have said it. Again, fix would be in the implementation, obviously. And then there are other scenarios like, oh, okay, does it really have, should it actually follow, say, saga pattern or some kind of a two-phase commit or a variant or those kind of things? Again, you need to do depending on the criticality of those steps and issues. You can choose different patterns. Again, then it becomes a design thing. All right. Now it's again the prevalence of the issues. It's again
Mm.
not like a one specific issue is a design issue is not easy. We can't say that.
Yeah.
It again like how common that type a similar type of issues happen, and related places where fixing one is not sufficient. You have to fix at every possible scenario cases, and still you are not confident, because that's another problem. You start fixing first one, you'll be confident. Two or three times later, even if you're not confident, even if you are, your testing team is not confident, your manager is not confident, or at some point, and
Yeah.
sometimes your support teams are going to be pissed off as well.
Mm.
Not sure if I can use that word, but yeah.
Most of the times, yeah.
So,
No, I think that makes sense. And typically, like most of the times, it depends is the answer. And because there's a lot of context to the specific problem you're looking at, and there's no easy way to say that, okay, this is the way you should look at this problem, right? That makes sense. When I talk about a specific programming language, right, there are multiple states. Okay, if it, for example, if it's a compiled language, you have some compilation happening, and then the runtime, you have some tests, and you do something about it. Do we have similar stages for a design specification language? For example, if I write a design specification, and then of course if there is some syntax problem, probably it will fail and give me that, oh, this cannot run. But let's say there is, the syntax wise, the design specification language is perfect. I haven't made any mistake. But is it possible to catch the design bugs itself at that level, where you say that, you know what, you have written this, but this could not be possible, probably because of some like obvious patterns or obvious mistakes that people make while writing the design specification itself, so I don't have to actually run the model checker.
okay. Right now, we are not there yet. Basically, you're saying static analysis on top of design specification language.
Yeah.
Right now, no. Right now, since I am also modeling after Python, it's even lower. So not
Mm.
all syntax errors are also caught completely in the compile time.
Okay.
Like you can have a state variable which is never declared, but you're trying to use it, can also be possible. So it's not
Mm.
really catching all those. Technically, it is possible to do that. But again, it's a addition on top of the language and with the tooling than the concept itself. But yeah,
Mm.
that's technically possible. We could.
Okay.
And again, there would always be like you have a common design pattern, and then can we say this is a design pattern and generate the specs for it? It should be possible. That's another thing I have to go through, look for all the common architectural patterns like saga, uh,
Yeah.
or whatever we have, and have an example here so that
Mm.
people can take that. Yeah, maybe I need to look into that.
Yeah. Okay, interesting. Talking about the things that are not yet in the system or in FizzBee, but you're planning to add, what are these? Like, what are the current limitations and what you're working on in the future?
Right now, what works more or less reasonably or very well better than the existing tools is the model checker and the language itself. So the core part of design specification is done.
Mm.
One thing is that it's not distributed, it runs in a single machine only, kind of a thing. So if you are doing a very large state space, right now it would be slow, and there is a limit which I need to work on for scale, and have a put more effort on the online tooling. Right
Mm.
now, the online playground, it works. So if you want to get started, you can quickly get started. Like any other programming language these days, everything has online playground, right? But
Yeah.
if I ask someone to install it locally, people are not going to hesitate. So that part is there, but I need to add more to the tooling,
Mm.
because in the longer term I can support more features on the online tool than an installable version. And
Mm.
the second one feature that we have right now, which works good, it again like everything can be continuously improved, but then it is already in a working state with a value add, would be visualizations. Like from the model it can generate like the state diagrams, the architecture diagrams, sequence diagrams, and again the whiteboard kind of an animation you can do it.
Yeah.
let's say an insertion sort. You can say that, okay, right now this is a variable points to this particular array, and you can click next, it can goes to the next one, so that you focus on that algorithm. Just an
Hmm.
example, but you,
Yeah.
you don't do it for insertion sort, but for a bigger system. But so those kind of diagrams all it can generate, so which again instantly you can embed it into your design docs to add value. What I am currently working on is model based testing. So generate all the unit tests and the required amount of end-to-end tests and integration tests to identify the certain types of bugs as well. Okay. And yeah, that's the current work. There are a few more. Okay, another one is performance modeling is also we support, which is not supported by any other modeling tool. Like TLA plus we don't do performance modeling. So
Hmm.
here you can say that, okay, you can do an estimate of what would be my tail latency. Like can my 99 percentile latency be less than 1 second? Can I support 5 nines of availability considering I'm using these resources? And what
Hmm.
will be the pattern? Like if I add a cache, how much my latency would change? How many retries would I need to support to have a error rate below say 0.1%? All those kind of things we can model as well, which again not many tools support. In fact, Taylor Plus and P don't support it. Okay, so this again another one, but again there again some kind of a usability related things I need to improve. Right now the tooling is not really where I want it to be. And the other one after the model based testing that I'm working on, next one would be more on a review platform where as I mentioned before, you can ask questions to the model. What happens in this scenario? Okay, how will it go
Got it.
back to this? Okay, can it ever reach this kind of a situation? And yeah, what are the different ways and what is the probability that it goes into this, and how much time it would be in this situation? Kind of questions
Hmm.
can be answered. Let's say I'm transferring money from one to another, we would do it immediately, but in case of an error, when will it recover so that the other person really gets some money? And what kind of guarantees can I give? Can I say that, okay, let's say 99.99 percentile chance that it would be delivered to the other person within 1 hour or something like that? Those kind of guarantees also we can do. So again, these are all more like a Q&A. So right now we have to have a specific like query language. Instead I want to add more into more of a LLMs to it, so that users can really ask without actually learning the specific query language. So yeah, that's another work I am doing. So after
Yeah.
that we can do more LLM related stuff, but these are my current focus for the next
Yeah.
few months.
Sounds good. You can call it Fizz Chat. Uh, that it's a really cool name. But yeah, that's really promising. That if I could do all that modeling before even writing a single piece of code, I'm still writing some code because design
Yeah,
specification is
it's
still
code. Yeah.
code. But yeah, I'm not implementing the systems, right? Like the cost itself is low, and fixing bugs would be easier. So that is really powerful. How should someone get started if they want to try FizzBee?
Uh, Obviously look into FizzBee.io. It has the tutorial and online playground. So I would say the minimum, the first three two pages actually, which it gives a basic introduction. Second one is this specifically about God classes.
Hmm.
And one nicer feature you can look at would be about roles, which adds the object oriented concept and visualizations.
Yeah.
So then you can get started. It should take, and try out a couple of examples. Now all the examples there, it would click a link, it would open it in the playground, so you can play around, make some changes to the system, to the spec, see the behavior. I do
Hmm.
have these small exercises after each example to say, okay, what, try this change, what happens. But then it would be nice if you have more ideas, you can try it on yourself as well. But again, I definitely need more examples to create. Right now I don't have that many compared to Taylor Plus, for example, has like around 300 or so examples in their GitHub project, whereas I have 40 examples. They're also very small, not
Hmm.
really a bigger problem. So I need to create more examples. That's on me. But biggest would be just looking at the websites and trying out those few examples. I probably have to create some patterns to look for. I think you pointed out like some example. Okay, this scenario, how do we go about modeling it? So
Hmm.
that's a difference between the understanding the syntax versus understanding how to model. from the problem. So that part, there is one page related to that, but I think I need to add a few more. Like, how do we model different types of communication behavior? Systems with retry, system with a lossy connection. FIFO queue, like Kafka, you can guarantee a specific order, whereas SQS you don't. And how do we define how do we model those scenarios? So
Hmm.
those examples, I have the document, but yeah, I would say go through that. And for any other questions, considering the system is new, you can ping me. LinkedIn is easy, Jayaprabhakar Kadarkarai. Maybe it would be in the description, or you can
Yep.
email me directly, jp@fizzbee.io.
Absolutely. I'll make sure I add all these important links in the description of this episode, and so people can reach out to you easily. Try FizzBee and write better systems and explain to their managers why it's important. Just kidding. But yeah, write better systems and reduce the cost of bugs, basically, that creep into your system. Cool. In the interest of time, I have hundreds of more questions and we can go on and on. But in the interest of time and keeping this episode scoped to what FizzBee is, we'll end this discussion right now. But I have more things to discuss, and probably we should jump again on another podcast episode where we talk about take a real world example and do something about it, probably write some code, and that would be really interesting. But yeah, thanks a lot for joining me. And it was really helpful, at least understanding how all these things works and how they differ from finding bugs at the implementation level, and also understanding how to think at a higher abstraction level. So I'm really glad we did this, and thank you.
Yep. Well, thank you. And it was great talking to you. Yeah. Looking forward for any questions or connecting with you again.